This is the overview of AI-driven campus fabrics with the Juniper Mist Cloud. These cloud-native architectures are based on three concepts: design, deployment, and operations. This overview will cover Day 0, Day 1, and Day 2 aspects of campus fabric deployments and how Juniper Mist has automated this process. Every EX switch shipping today has a unique claim code, and this code can be used to automatically onboard devices directly to the Juniper Mist Cloud. You can also use the Mist AI app to easily claim switches by scanning the QR code and immediately onboarding your device. Once the devices are installed and powered up, you will automatically see them in the switch's dashboard. Once the devices are onboarded, you can now deploy the campus fabric with no console cables needed. Here are the steps involved. First, choose the topology you want and assign device roles. Juniper supports various topologies: EVPN multi-homing, which is a two-tier deployment, campus fabric with core distribution, or IP close, with the last two being three-tier architectures. So after we choose the topology and assign device roles, examples are collapsed core, access, core distribution with access. Step 2 is to configure the networks of interest. Step 3, define the physical connectivity. Step 4, apply the configuration, and that's all that is required. Let's take a look at a simple example of a campus fabric deployment. We are looking at a multi-homing campus fabric topology with two collapsed cores, the EX4400 devices, and an access switch, which is an EX4300. Our network has 4 VLANs: employee, contractor, guest, and IoT. We want the employee and contractor to be internal and be able to talk to each other, and the guest and IoT will be VRFs of their own. Let's look how we would configure EVPN. The first step is selecting the topology in the UI. EVPN multi-homing in this case. Now we select the devices, the two 4400s which are set up for ZTP. We will add the EX2300 as part of the access. Now let's configure the user networks and add the 4 VLANs: employee, contractor, guest, and IoT. The gateways are on these core devices and will provide either DHCP or static IP addresses. Now, segmentation. We associate employee and contractor to internal resources, and the other two will be VRFs of their own. We need to allow communication between the access and core switches and make sure the 4 VLANs are allowed. The rest is done automatically, including the MTU, which is automatically set. The last part is how the devices are physically connected. How are the cores connected to each other? And how are the cores connected to the access switches? We use ESI lag. Now just select 2 uplinks connected to the core devices. We are done and will confirm. Now all of our EVPN changes are done and saved to the cloud. Now we look at Marvis Actions, which is really the morning coffee view of the network, showing the important issues that you, the administrator, should be looking at. Across 1,127 devices and 55,000 ports, Marvis Actions has detected 25 bad cables, showing the exact port and site details, 2 negotiation mismatches, 4 devices experiencing continuous port flaps. We also show you persistently failing clients. If a client is continuously failing authentication, it could slow down your network and your Radius server. Marvis Actions is designed to show you AI-verified problems that you can either solve or let Marvis open a ticket for you with all of the relevant information.